Hi everyone, this is section 0.10 on more algebraic manipulations, gymnastics. So for example, and this is your bread and butter in calculus, you do this all the time. When you want to find the derivative or an integral of something like this, then you want to break it down into a linear combination of powers of x. That is, a number times x to a number plus a number times x to a number. That's called a linear combination of powers of x. And you want to take the derivative or the integral of this right-hand side term by term. Okay, so let's get an equivalent expression here. Fill in the boxes below with appropriate simplified real numbers so that the left side is equivalent to the right side. All right, well, we have a big old plus sign here, so that does suggest that we have to break up this fraction. And we can do that. We can break up a fraction through the primary plus or minus signs in the top, the numerator. Okay, so when we do that, we get, oh, and before we even go there, the fourth root of x. How do you write that as a power of x? The fourth root of x. That's x to the 1/4. The fourth root of x is x to the 1/4. All right. So you can start by either splitting the fraction or doing this first. Again, the order might not matter. Okay, so here I rewrite the fourth root of x as x to the 1/4, and then I split the fraction through that primary plus sign in the top. Re-express that as a sum. So I have 7x, or 7x to the first, over x to the 1/4, plus 3 over x to the 1/4. I'm sharing that denominator. I'm reversing the addition of fractions. Okay, now over here, when we divide powers of x, what do we do with the exponents? We subtract them. 1 minus 1/4 is 3/4, and we keep the 7 as the coefficient. The x to the 1/4 down here can pop up as x to the negative 1/4. Because that guy down there is a factor of the bottom, it is the bottom, it can pop out or up as x to the negative 1/4. So we're basically done. We have 7 times x to the 3/4, which is 1 minus 1/4, plus 3 times x to the negative 1/4, and we can fill in the blanks. 7x to the 3/4 plus 3x to the negative 1/4. And this is a situation where we do want negative exponents in our final answer. That's the only way we can do this. We do get negative exponents in our final answer, but again, in this form, it's easier to take the derivative or the integral of something like this if you have this kind of format. All right. Now we can split a fraction through the top, but do not split through the bottom. 1 over x plus y is not 1 over x plus 1 over y. In fact, there are no real values for x and y for which that's true, that these are equivalent. So don't split like that. You do not take reciprocals term by term. That doesn't work. So what are some more gymnastics here? Here's an example. Let's say I have x divided by 2/3. If you divide by 2/3, you're multiplying by what? You're multiplying by the reciprocal, 3/2. If you don't believe me, multiply top and bottom by 3 over here, and you'll see. But if you divide by a non-zero number, you're multiplying by its reciprocal. But it also works in reverse. If you multiply by a non-zero real number, you're dividing by its reciprocal. And this comes up with equations of ellipses. So if you take x squared and you multiply by 9, or 9 over 1, then you're really taking x squared and dividing by what? The reciprocal, 1/9. Likewise, if you take y squared and multiply by 3/4, that's the same as dividing y squared by what? The reciprocal, 4/3. So this works. When you're multiplying by a non-zero quantity, then you can divide by the reciprocal, and you're doing the same thing. It's the reverse of what you were used to doing. Before, you interpreted a division as a multiplication. Now we're interpreting a multiplication as a division, but we're still taking reciprocals. compensation. How can we express x over x plus 1 as something like this? So here's the idea. X over x plus 1. How can we write it like this? Well, how do we get a 1 here? We want to make a twin up here. To get a 1, we can construct x plus 1 over x plus 1. So we can make a 1 here by adding 1 to the top. But wait a minute, I can't change a problem because I feel like it. Otherwise, math tests will be easy. How do you pay for adding a 1 on top? By subtracting a 1 also on the top. Now, some of you might have said, oh, wait, can I add 1 on the bottom? Would that work? No, that doesn't work. For example, if you eat 1/2 of a pizza, is that the same thing as eating 2/3 of a pizza? Hey, I'm adding 1 to the top and adding 1 to the bottom. So if I eat 2/3 of a pizza, is that the same as eating half a pizza? That's a great diet, but it doesn't work. That's illegal. You cannot add 1 to the top and the bottom. That's illegal. There's no rule that says that. You can do that. So we don't do this. You pay for adding 1 to the top by subtracting 1 from the top. This is legal because then you're just adding 0 to the top. And then we can break the fraction through at that minus sign. And what happens? We get x plus 1 over x plus 1, which is 1. We get the minus sign. And we get 1 over x plus 1, which is how we fill in the blank. If you didn't get that, don't freak out. But I'm just showing you the kind of things you can do with compensation. If you add 1 to the top, you can subtract 1 from the top. In fact, you better subtract 1 from the top to maintain equivalence. And then you can do some gymnastics. This next one's a bit easier. And this comes up in calculus with integration. Let's say you have a quantity like this. In calculus, you're going to want to multiply it by 4. You'll see why. It's in the technique of integration with U substitutions. Okay, now if you take this and you multiply by 4, how do you compensate for multiplying by 4? Dividing by 4. Or multiplying by what number? Dividing by 4 is the same as multiplying by 1/4. So here we maintain equivalence. This is legal. We're multiplying by 1. If you multiply by 4 and 1/4, you're just multiplying by 1. That's legal. And yes, we pull this stunt in calculus. So here's some algebraic gymnastics that will haunt you throughout calculus. Until then.